The first method I want to look at for solving systems of equations is the substitution method. The first step in the substitution method is to solve one of the equations for one of the variables. It actually doesn't matter which equation you start with or which variable you solve for. There are a couple of guidelines to make it a little bit easier that I'll talk about as I do some examples, but overall it really doesn't matter which equation you pick or which variable you solve for. We're then going to substitute this into the other equation. Let's say we solved the first equation for x. Then I'm going to substitute this expression in for x into the second equation. We will then solve this equation. It's now an equation in one variable that we will need to solve. We're then going to substitute this solution back into the result for step one. When we solved our one equation for one variable, we're going to use what we got for step 3 in that particular equation. And then we'll solve once more. Let's look at some examples. Let's look at the equations x plus 3y equal to 4 and 2x minus 5y equal to 8. I actually want to solve the first equation for x. In general, I like to solve these equations for whichever variable has a coefficient of 1 or negative 1. So if I take this equation, I have x plus 3y equal to 4. I can subtract 3y from both sides, and that leaves me with x equal to 4 minus 3y. That was step 1. Step 2 takes my other equation, in this case equation 2, and it's going to replace this x with this expression I found in step 1. So I have 2 times 4 minus 3y minus 5y equal to 8. Distributing, 2 times 4 is 8. 2 times minus 3y is minus 6y. Minus 5y equal to 8. Simplifying, I have 8 minus 11y equal to 8. I can subtract 8 from both sides. That gives me negative 11y equal to 0. And dividing both sides by negative 11, I get that y is equal to 0. So step 2 did that substitution, and then step 3 was me solving this equation for y. Step 4 is to then plug this back in to the result for 1. So x is equal to 4 minus 3 times y, which we just found to be 0. And then step 5 is to solve this. 4 minus 0, or x equal to 4. So my solution is 4, 0. My next example, 3x minus 4y equal to 1, and negative 2x plus y equal to 6. I want to start by solving the second equation for y. Since, like I said, I like to solve things with coefficients of 1 or negative 1. I'm going to add 2x to both sides. That gives me y is equal to 2x plus 6. My second step uses my other equation, in this case the first one, 3x minus 4y equal to 1. And in this case, I'm going to change the y to this expression that I found in step 1. This tells me I have 3x minus 4 times 2x plus 6 equal to 1. Step 3 then says to solve this equation. Distributing, negative 4 times 2x is minus 8x. Negative 4 times 6 is minus 24. 3x minus 8x is negative 5x. Minus 24 equal to 1. We can add 24 to both sides. That gives me negative 5x is equal to 25. Divide both sides by negative 5 to get x equal to negative 5. Step 4 then uses this equation that I had in step 1, y equal to 2x plus 6, and substitutes in negative 5 for x. So 2 times negative 5 plus 6. Y equals negative 10 plus 6, or negative 4. So my solution is negative 5 comma negative 4. Next, let's look at 2x plus y equal to 3 and negative 4x minus 2y equal to 5. I'm going to start by solving my first equation for y. I will subtract 2x from both sides, and that leaves me with y is equal to 3 minus 2x. I'm then going to take my other equation, my second equation, and I'm going to change the y to 3 minus 2x. That tells me I have negative 4x minus 2 times 3 minus 2x equal to 5. Negative 4x, and then negative 2 times 3 is negative 6. Negative 2 times negative 2x would be plus 4x equal to 5. Negative 4x plus 4x is 0, so the left-hand side is just a negative 6 equal to 5, which is not possible. This is the case where we have no solution. As we're solving these no solution situations, we'll end up with these false statements like negative 6 equal to 5 or 2 equal to 7. And if we ever get this where all of our variables cancel and we're left with a false statement, it tells me I'm going to have no solution. For my final example, let's look at 3x minus 9y equal to 12 and x minus 3y equal to 4. I'm going to solve my second equation for x. In order to do that, I will add 3y to both sides to get x equal to 3y plus 4. I'm then going to take my other equation, which is my first equation, and I'm going to change the x to 3y plus 4. So I have 3 times 3y plus 4 minus 9y equal to 12. 3 times 3y is 9y. 3 times 4 is equal to 12 minus 9y equal to 12. 9y minus 9y is going to cancel, and I end up with 12 equal to 12. This time, instead of a false statement, I ended up with a true statement. All of my variables canceled, and I have a true statement. This is the case where we have infinite many solutions. And we're actually going to use our result from step 1 to properly write this. Essentially, instead of x, I'm going to write 3y plus 4. And for y, I'm just going to write y. So if you pick any number for y, we can find a valid point that would be a solution to this particular system. If you tell me that y is equal to 0, I can plug it in and get 4, 0. If you tell me that y is equal to 1, I can plug it in and get 7, 1. But this ordered pair shows us what the solutions will look like.